Imagine observing yourself in a mirror that doesn't just reflect light, but time itself, not looking at your face, but into the infancy of the universe when existence was still wrapping itself around its first breath. That's just what the James Webb Space Telescope was built to do. But what it found when it looked deeper than anything before it wasn't infancy. It wasn't the cradle of the universe. It was a contradiction, an impossibility on a cosmic scale. And what it saw, what it revealed to us, has not just stunned astronomers, it has shaken the very skeleton of modern physics. For a long time, scientists believed they had a pretty solid grasp on how the universe evolved. First came the Big Bang, then a dark age, followed by the steady, slow birth of stars, life, and eventually galaxies. When we look further back, the simplest things should be basic. Faint particles, unorganized, chaotic hydrogen clouds in space. But when Webb turned its golden mirrors toward a remote and supposedly quiet region of the sky, one of those vast black stretches where we expected nothing more than darkness, it captured something that was never meant to be at that time, a fully developed galaxy. Rather than a hazy blob of gas scattered about, it was a complex, rotating system of stars, complete with spiral arms and a monstrous black hole at its heart. Not just formed, but thriving. This was not a mistake. More and more data came in. That primordial space gave rise to galaxies, fully structured, chemically mature, and stable under gravity. It was as if the cosmic clock had jumped ahead, avoiding the slow grind of billions of years of evolution and landing in an era of impossible maturity. And for each observation, a terrifying inquiry started to echo more strongly in scientific circles. What if everything we believed was true? Is it true that we knew about the beginning? When the Webb telescope first captured the image of what appears to be an impossibly mature galaxy sitting over 13 billion light-years away, it was anticipated to be yet another dim, ancient smear of light, barely discernible from background noise. But instead, what stared back was nothing short of architecture with class, arms that spiraled, wrapped like ribbons of starlight, dense star clusters orbiting in harmony, and a dense core pulsing with energy. This galaxy wasn't forming, it was created, and not just barely. It looked like something we'd expect to find several billion years into the universe's timeline, not within the first few 100 million years after the Big Bang. To comprehend the reason for this baffling discovery, you have to understand how galaxies are thought to evolve. In the early universe, matter was spread thin and uneven, gradually pulled together by gravity into clouds that collapsed into stars, which then grouped into galaxies over long periods of time. However, Webb noticed that the entire procedure had already completed far too quickly. That galaxy hadn't just taken shape, it had prospered. The laws of astrophysics did not permit this. It was similar to finding a fully grown, ancient redwood tree sprouting from freshly planted soil. Even more puzzling was that this wasn't an isolated phenomenon. Webb came across multiple examples, galaxies across different regions of the sky, all displaying levels of organization, maturity, and complexity that were flat out impossible according to our current knowledge of cosmic timelines. This wasn't just a glitch, either. The instruments were working flawlessly. What had gone wrong? Was the foundation of our theories flawed? After analyzing the spectral data, the fingerprint of light that reveals the components of these galaxies, astronomers received yet another shockwave. Not only did these galaxies exist, but they contained the chemical signatures of elements that shouldn't have been there yet. Oxygen, carbon, iron, even. These elements don't come from nowhere. They're forged in the hearts of massive stars and only released into the cosmos through supernova explosions. That procedure requires time. First-generation stars, called population 3 stars, burn hydrogen and helium. Then they die, scatter their contents, and eventually second-generation stars are enriched from birth with heavier elements. That entire sequence should have taken hundreds of millions, if not billions, of years. But here they were, galaxies less than 400 million years old, exhibiting a long line of stellar deaths and rebirths. That would imply not only that the first stars had formed and died, but that the cycle had already repeated more than once. The early universe, it seems, wasn't quietly waking up. It was sprinting, forging, burning, and exploding in ways that nobody expected. And the presence of these elements raises even deeper questions, because these are not just the ingredients for stars. They are the foundation for atmospheres, planets, and possibly life. Finding them so early is like stumbling upon a healthy coral reef at the base of a volcano that only erupted yesterday. The timelines don't just feel rushed, they feel broken. Just as scientists were beginning to believe it couldn't get more confounding, the center of one of these ancient galaxies provided the most bizarre surprise of all. Its heart contained a supermassive black hole, estimated to weigh more than 1 billion times as much as our star. In today's universe, that would be incredible. But in the early universe, that's not just unlikely, it's cosmologically absurd. You see, black holes are thought to grow gradually. They begin as the shattered remains of stars, then feed over billions of years by consuming other stars, gas, and dust. Even the most optimistic simulations with accelerated growth models and constant feeding cannot explain how such a colossal black hole could form within 400 million years of the Big Bang. It would be like finding a fully grown adult who was born within the last hour. The math is ineffective, and yet there it was. The gravitational signature was unmistakable. The revolving stars, the energetic emissions, the distorted space around it. Everything pointed to a gaping black hole, total adolescence. It did not develop, it arrived. Now, scientists are amused by revolutionary theories. Black holes in the beginning were a direct result of the collapse of extreme variations in the area's density in the early universe, or perhaps the influence of dark matter or exotic particles accelerating their development. However, they are not modifications to existing models. These are brand new blueprints for reality. What do you do when you've seen everything defy the instructions you've been given? For numerous cosmologists, the response is unsettling. You alter the regulations. The James Webb Telescope hasn't just presented us with anomalies. It has revealed a universe that appears to be acting in reverse, where complexity comes before simplicity, and where ancient light carries blueprints that ought not to be there. Some scientists now propose that dark matter, once thought to be inactive, might have played a more assertive role in shaping the early universe, forming scaffolds that fast-tracked galaxy growth. Others suggest that time itself may have flowed differently in the beginning, stretched and warped in ways we can't yet detect, enabling entire epochs of evolution to occur in what we perceive as fleeting flashes. There is also the most terrifying concept of all. Perhaps the beginning of the universe was similar to the one we currently have. Maybe the level of complexity is not the end of cosmic development, perhaps it's the beginning. As researchers kept collecting data, they began to notice something even stranger, something that had nothing to do with the brightness or the mass of these galaxies, but rather the forms they repeated. Using deep learning algorithms, scientists found that the distribution of these ancient galaxies followed a very specific, repeating mathematical ratio, one eerily similar to the golden spiral. This was not just aesthetic, it was structure, a hidden geometry that extended over billions of light years, linking star systems and galaxies in elegant alignment. The very layout of matter seemed to follow a fractal logic, as if the universe were encoded, starting with a design that reflected across scales. It wasn't just coincidence. The spiral arms, the rotational symmetry, the orbital distances, the high-resolution images from the Webb reveal that our belief in chaos in the early cosmos may, in fact, have been patterned, predictable, like fingerprints. But what are fingerprints? A fundamental rule that goes beyond physics, or something significantly more alarming, evidence of deliberateness incorporated into spacetime itself. One of the Webb's most controversial findings came not from a galaxy or a black hole, but from the hazy chemical trace left behind in a seemingly empty region of space, an ancient void between stars thought to be clean. Yet, the telescope's spectrometers found something inexplicable: complex organic molecules, not merely methane or polycyclic aromatic hydrocarbons, but the elements that make up amino acids and, by extension, life. These chemicals weren't attached to planets. They weren't fluttering about inside stars. They were drifting, aimless, yet present despite 13 billion years. This sparked concern because the implications went beyond the biological. It meant that the ingredients of life had existed nearly since the beginning, not subsequently formed in solar systems like ours, but incorporated into the cosmic fabric almost immediately. If that's true, then life is not a random alignment. It's a feature, a constant, a thread woven through the universe from the start. The unimaginable, it seems, was not limited to space, it was microscopic. Then came the image that threw even the most skeptical minds into silence. Deep within a high redshift cluster, the Webb found a structure in galaxies that was overly perfect, 6 galaxies positioned like petals around a central object, equally spaced and rotating in near-synchronized orbits, like some cosmic dance choreographed with purpose. Scientists called it the flower. Despite their efforts to justify it as a statistical blip or a coincidence of gravitation, no natural model could replicate its accuracy. It was a frozen astronomical sculpture, light from a time before Earth had formed. Some proposed gravitational lensing, others suggested quantum symmetry from the beginning of the universe's turbulence. However, a few quietly wondered aloud whether this might be something entirely different, such as a compass, a calling card left in plain sight, intended only to be seen by humans after they had evolved sufficiently to comprehend it. Last but not least, the most terrifying theory to emerge from all of this, that the very act of observing these ancient galaxies might be influencing them retroactively. In quantum physics, the observer effect describes how the act of simply being measured can alter a situation. But what if this principle extends beyond particles? Imagine the universe, on some unfathomable level, is capable of paying attention that by constructing the James Webb Telescope and observing the early universe with this first-of-its-kind clarity, we not only discovered secrets but awakened something. This theory, once dismissed as philosophical nonsense, is being taken seriously by a small group of Webb-savvy physicists who spot patterns in data that shift depending on how and when they are processed. A few pictures appear to subtly change over time, as if the universe itself is reacting to being observed. If true, it would mean we're not only pioneers. We're participants, co-authors of the very reality we seek to understand. What the James Webb Space Telescope revealed was never about stars, black holes, or dust drifting through time. It was about truth, a truth so immense, so ancient, and so intricately woven into the fabric of everything that to witness it is to feel the scaffolding of the real world shake beneath your feet. We did not merely observe the unthinkable. We unlocked it, not by coercion, but by daring to ask questions that no civilization before ours had the technology or the audacity to pose. Galaxies to mature, chemistry to complex, patterns to perfect, signals to aware. What the Webb revealed is not simply that the universe is more enigmatic than we had anticipated, but that it may be aware of our curiosity. Perhaps, for the first time in history, the universe spoke back not in words, but in light, in pattern, and in echoes that bend across time itself. Possibly, we didn't find the edge of the universe.